All right. Good morning, algebra students. Glad to be here with you. I want to record today on systems of linear inequalities. Of course, I got to get you started off in the right way. I'm actually here in the middle of my honest geometry class, so they're going to correct any mistakes that I might make, which of course never happens. But you know, on the off chance that today is one of those days. And Joel just walks right by the camera. Thanks, Joel. All right. Here it is. The oldest computer can be traced back to Adam and Eve. The oldest computer. Do you know what kind of computer it was?
Apple.
Of course, it was an Apple, of course. But it had a very limited memory. Only 1 byte.
Oh. That was funny.
Wow, that's like kind of the best reaction I've got from any of my jokes in a long time.
It's not your joke, Bill.
Well, I told it. Thanks. Okay, this is going to be, okay, I got to get through this. All right, systems of linear inequalities. The thing you should be sure to have as we're going through this is graph paper, because this is involving graphing. And the thing about systems of linear inequalities, this is probably more likely what you would see in the real world, because the other ways of doing it we've done so far, you arrive at precisely one answer. With systems of linear inequalities, it gives you a range of answers, and that's generally how you do things. So here's your range. With these two limitations, what are our possible values? And so that's what systems of linear inequalities is all about. What you will learn how to check the solutions of systems of linear inequalities, how to graph them, how to write them, and then use systems of linear inequalities to solve real-life problems. All right, so a system of linear inequalities, well, that's really just very basic. Of course, it's two equations that have an inequality. I know we haven't done inequalities since first semester, so we've got to get woken back up again and get going. Ava, do me a favor. Answer that for me, see what she needs. Okay. A solution of a system of linear inequalities in two variables is an ordered pair that is a solution of each inequality in the system. So as an example, to check solutions, it says tell whether each ordered pair is a solution of the system of linear inequalities. So here's your two equations. I'm going to write them on the board. Y is less than 2x. And the other one, y is greater than or equal to x plus 1. So then what they do is they come down and they give you a point. They say, okay, you've got this coordinate pair, 3, 5. And so you just plug it in and see if it fits. So, is 5 less than 2 times 3, which is 5 less than 6? Is that true? Of course it is. So then I come over here. Is 5 greater than or equal to 2 plus 1, which is, of course, 3. Is 5 greater than that? It is. So that ordered pair fits that system. All right, the other one they gave us is negative 2 and 0. You just do the same thing, negative 2 and 0. So 0 less than 2 times negative 2. Is 0 less than negative 4? No, it's not. So we've already failed. No need to check the other one. Okay? That's all you do. That's really easy. Just plug them in and see if it fits the system. At this point, you all should have boards with you, the whiteboards and your markers. So just really quickly, I'm going to pause here. You're not going to pause here, but the instructor pause the video so that the kids can work through these two problems and then start back up again when they're in about 2 or 3 minutes. Okay, so we're going to check these. I'm just going to check them quickly verbally. You should have it written down. So number 1, the coordinate pair is negative 1 and 5. And so you ask yourself, is 5 less than 5? Right? Literally, there's no x value in this first one, so you just put the y value in. Is 5 less than 5? Of course it's not, so that's failed already. You can skip and move past that one. So at number 2, it's 1 and 4. Plugging those in, let's check the easiest one first. Put the 4 in for y. Is 4 greater than 1 minus 1, which is 0? Is 4 greater than 0? Of course it is. Up here I have 4. I put it in here. 3 times 1 is 3 plus 1 is 4. Is 4 greater than or equal to 4? It is. It's equal. So it's passed both those tests. Okay? That's all you do with that. That's really basic. That's really easy. All right. Next section is graphing systems of linear inequalities. And here's what you do when you graph them. You graph each inequality in the same coordinate plane. Have your graph paper out for this now. Find the intersection of the half planes that are solutions of the inequalities. This intersection is the graph of the system. So if you look here at this one they drew out, they graphed two different lines, and yes, you need to continue knowing how to graph. It's critical for this. So this one is y is less than x plus 2. Y less than x plus 2, here's what that line looks like. Because it's less than, it's everything below that line. So everything in blue is this inequality. Okay? The red one, y is greater than or equal to 2x minus 1. So here's your red line, and because it's greater than or equal to, it's everything above. Okay, all of the red. The solution to this system of linear inequalities is where these, the blue and the red, are together. It's this blue and red. What does blue and red make? Purple, right? Your color scheme for you artists, right? Yes, use here. All right. So where they intersect here, this whole section represents all the possible solutions for these two inequalities. Any value in this graph area will fit both of those. Anything outside of that, it will only fit one. All right? So that's graphing systems. Let's see. So here's an example. Graph the system of linear inequalities. I'm going to go ahead and do this. I know they did it, but I just want to remind you guys how to graph. So y, and of course I'm doing this by hand on a computer screen. That's going to be fun, but whatever. Y is less than or equal to 3. All right, so got line ready. So here's 3. And again, if it's just y is less than or equal to 3, that is just a straight line. At y equals 3. And it's less than or equal, so it's everything below this. Right? Y less than or equal to 3. All right. The other one is y is greater than x plus 2. Change the color. Go to red. Y greater than x plus 2. Okay? So when you graph that, of course, you go to the y-intercept. What's my y-intercept of the red equation?
2.
2, right? Okay, what's my slope?
1.
1, right? The number in front of the x, when it's invisible, it's 1. So we go up 1, over 1, up 1, over 1. I went up to that twice. Down, over. Draw your line. Okay, there's your y is greater than x plus 2. Because it's greater than, it's everything above that line. Okay, and so now we look to see where they intersect. And as messy as this is, hopefully you can see. I will go with purple. I should use the word, just make it thick. There we go. Here's where they intersect. Okay, so that represents the solution to the system of linear inequalities. Isn't that pretty? So artistic. So artistic. All right. And just confirming, they drew it in a much nicer fashion, I'm sure here. They certainly did, but you can see it's the same thing. All right, graphing a system of linear inequalities with no solution. I'll just show you this rather than graph it myself, okay? Well, I would, just to help you make sure you remember how to do this, because they have these equations. What form, let's test my crew in here. What form do they have those equations written in right now?
Standard.
Standard form, that is indeed correct. That is written in standard form. I would suggest rewriting it into, what is the easiest form to graph? What would you call it? Slope intercept. Yes, slope intercept. Okay, so for the first one, let's bring the x over by subtraction. I'm going to subtract 2x from both sides, right? And rewrite it as y is less than negative 2x minus 1. And then bring the 2x again over to the other side for the second one. And I have y is greater than negative 2x plus 3. Okay? So, when you graph those, okay, the one in blue is y equals negative 2x minus 1, and the one in red is y is greater than negative 2x plus 3. Because, let me zoom it in, because the one that's blue, because the one that's blue is less than, it's everything below it. This is greater than, it's everything here. As you can see, these two never intersect. How could we have known that ahead of time? Without graphing it, how would I know, looking at those equations, that those two would never going to intersect? Anybody recall or remember? What about their slope?
Their slope's the same.
The slopes are the same, what does that mean?
Parallel.
They're parallel lines, right? If their slopes are the same, they're parallel lines. Now, the only thing that would, of course, make this different, though, where parallel lines can have systems, is if the blue was greater than and the red was less than, then everything in between them is your solution. But because this one's less than, this one's greater than, it leaves a gap where they never intersect, and so there is no solution to this system. All right, your turn to practice. 3, 4, and 5. Okay, so again, teacher, at this point, please go ahead and pause. Give them a chance to graph this. This will probably take a little longer. Give them about 5 minutes if need be, and then come back, okay? So practice graphing. Be back here in just a second. All right, so we're back. All right, I need a graph. I gotta clear my graph. All right, so the first one, I have these two equations. One is already written in slope-intercept form. Let me just rewrite the other one in the slope-intercept form. Y is less than or equal to x. So 0 just goes away. All right, so y is greater than or equal to negative x plus 4. Y, I probably need to have it on the fat side. There we go. Y is greater than or equal to, let's say x plus 4. No, negative x plus 4. Negative x plus 4. So 4 is my y-intercept, 1, 2, 3, put a dot. Slope is negative 1. Okay, down 1 over down here, here. Okay, and because it's greater than, it's everything here. Okay, the other one was y is less than or equal to x, if I recall right. Yeah. Change color, blue. The y-intercept is 0, and that one looks like, okay, the slope is 1. Okay? That's y is less than or equal to x. So what that means is it's everything down here. So clearly our intersection is all this stuff right here. Hopefully those two are in between. I'm not going to take time to change colors. Okay? That's your system. All right, on the second one, clear my board, there we go. Second one, they're already in slope-intercept form. That's nice. Y is greater than 2x minus 3. Y is greater than 2x minus 3. Let's see if I did it right. Yeah. So y-intercept is negative 3. Slope is 2. Up 2 over 1. Up 2 over 1. Draw my line. Okay, not a great line. Who cares? All right. Next one. Y is greater than or equal to 1/2 x plus 1. Equal to 1/2 x plus 1. So here, and 1/2 of 1 over 2. 1 over 2 of 1 over 2. Draw that line. And so then you can see, I didn't draw it all the way out, but the point where they overlap is this zone right here.
Shouldn't your first equation be a dotted line?
What's that?
Shouldn't your first equation be a dotted line?
Oh, yes, it should. Thank you, Sierra. Yes. I hadn't noted that yet. If you go back to this equation, let me erase what I just did with that color in. The equation for the blue is y is greater than 2x minus 3. So when it's not greater than or equal to, what I should be drawing, and what I want you to draw, is a dotted line. Okay? And that way you're indicating it doesn't include the line itself. right? Your dotted line versus the other one is greater than or equal to, so the red line is solid, right? So if it's not equal, it's dotted. If it's greater or equal to, it's solid. Thank you. All right, last one. It's all clear. It'd be nice if I could just push one button and just clear everything. All right, so neither one of these is written in slope-intercept form, so let's quickly do that. The first one will be, I'll add 2x, and I get y is less than 2x plus 4. And the other one, I'm going to subtract 2x, y is greater than negative 2x plus 4. Okay, so y greater than positive, or y less than 2x plus 4, and y greater than negative 2x. So y greater than 2x plus 4. You're right. No, y less than. Dang it. Okay, so that looks like this. Plus 4 is your y-intercept. Slope is 2. Up 2 over 1. Down 2 over 1. Draw my line. And I didn't draw it right. Try it again. Dash, dash. Obviously with a ruler this would look much better. All right, and then the other one, I'll go red. Just double checking. Greater than negative 2x plus 4. Same y-intercept here. Okay, and then it's down 2 and over 1. And then up 2 and over 1. And this is again a dashed line. Question. Is there a system to these linear inequalities? Is there a solution to this system of linear inequalities? I have a yes. I have another yes. Is there a, what do you think the solution is? Oh, let me color. So y is greater than, okay, is here, and then less than down here. Right, so your solution is right there. Okay? They'll tell. And then we'll work on it together in class on Monday too. All right, let's see what we're doing next. Writing a system of linear inequalities. So now you're given the graph, and then you have to write the inequalities. Okay, so I look here. I know you're going to groan. Oh, I don't want to do that. You'll be fine. So I look here. Let's do the easiest one first. The easiest one to me is the horizontal line. First of all, note that it's solid, so it's going to be either greater than or equal to or less than or equal to. Okay? And it crosses at the y of negative 2. So, and if you notice, here is what our solution is. Okay, this area represents the solution of these two lines. So for this line, it's y is greater than, because it's the solution above it, negative 2, greater than or equal to. So the first equation is represented by y greater than, why did I write it this side? I don't know. Y greater than or equal to negative 2. Okay, that's it. Now I look at the dashed line, so it's either going to be greater than or less than, no equal sign. And I note here it crosses right at the origin, so there's no y-intercept. Then the other thing you need to note is your slope. So where it crosses here, the next time it crosses another intersection is up 1 over 1. Up 1 over 1. My slope is what?
1.
1. You go up 1 over 1, your slope is 1. Because this is the solution area and it is below this line, this is a less than. Okay, so it is y is less than, the slope is 1, so it's just x, and there's no y-intercept. That's it. Done. Okay, easy. All right, moving up. It's probably going to be your turn to practice. No. Writing, okay, write a system represented by the graph. Okay, we have one more to do. So I look here, I'll choose the vertical one first. It's a solid line at x is 3. My solution area is on this side of things. It's less than. So this is x is less than or equal to 3. Starting at 3 and over. The other one, what I look for here is where does it cross? It crosses right there, okay? So I'm going to look for, well, first of all, let me back up. My y-intercept here is -1. Then the next time it crosses is up here. It goes up 2 and over 3. So that's my slope, up 2 over 3. So that line, and again, it's here, and it's everything above it, so it's dashed, so it's greater than. So it's y is greater than, my slope was it up 3 and over 2? No, up 2 and over 3, 2/3 x, and the y-intercept was -1. Okay, so there's my two equations representing this solution. All right, so we've arrived at your turn to do it. You've got 2 graphs to do. Instructor, please pause here for the kids to write at this time. All right, and we're back. Okay, for number 6, again, I've got a vertical line. It's dashed. The solution side is everything over to the left. So that one is going to be x is less than where it crosses at 3. Okay, I look at the other line, it's x angled. My y-intercept is at +2. The next time it crosses it down here, it's down 2 over 2. So that's down 2 is -2. Over 2 to the right is +2. So the slope is, what's my slope of that line? -1. The negative slope. So you should have here y is a dashed line, and the solutions are below it. Y is less than -x plus where the y-intercept was at 2. Okay? All right. Number 7. They're both solid lines. Let's depict this one first. Okay? Y-intercept is 1. My slope is down 1 and over 2, so that's -1/2. And the solution is above it. So it's greater than. So you write y greater than or equal to, the slope is 1/2 x, and the y-intercept is 1. That's a terrible looking 2. There we go. Then the next line is here. The y-intercept is right down here at -3. The next time it hits the intersection is up here. So 1, 2, 3, 4 over 2. That is a slope of 2. So it's y, and again now everything here though is below that line. Okay, as the line goes up, everything's below it, so it is less than or equal to, the slope we said was 2x minus the y-intercept. Okay, so there's your solutions. All right, last thing, solving real life problems, modeling with mathematics. You have at most 8 hours to spend at the mall. Oh, and at the beach. I'm like, 8 hours at the mall? Shoot me now. Sounds like Christmas shopping, my least favorite time of the year. All right, you want to spend at least 2 hours at the mall. No, you don't. Gentlemen, you don't want to spend 2 hours at the mall, do you? Yeah, no. And more than 4 hours at the beach. That actually sounds miserable as well, but anyway, we'll do it anyway. Write a graph, a system that represents the situation. All right, you have at most 8 hours to spend at the mall, at the beach. You want to spend at least 2 hours at the mall and 4 hours at the beach.
That's how long the drive is.
There you go. Understand the problem. You know the total amount of time you can spend at the two and the minimum time you're going to spend at the other. So make a plan. So let x be the number of hours at the mall and let y be the number of hours at the beach. And so they graphed it based on the way it was written. So at most 8 hours. If you remember when we were talking about putting phrases into expressions, at most is the same as less than or equal to. So when you combine the two times, the times at the mall, the times at the beach, combine those together, less than or equal to 8. We want to be at least 2 hours at the mall. Sorry. That at least means the opposite of what you think it sounds like. You're thinking less than when you see the words at least. It actually means the opposite. Greater than or equal to. 2 and more than 4 hours at the beach. That's easy. Y is greater than 4. And then you graph those three things. 3 really simple equations to graph. And here's what that looks like. Time at the mall and at the beach. Okay? And so on the vertical line, the y-axis is hours at the beach, and on the horizontal axis is hours at the mall. When you graph each of those, it gives you the solutions of what will possibly fit all limitations of this graph. So if you chose, obviously the easy one to choose would be here. That would be you were 5 hours at the beach and 3 hours at the mall. Okay? Anything in between that. For instance, you could be 5 hours at the beach and 2.5 hours at the mall, and it fits the solution. Anything in that little triangle will is your solution. All right. I think that's going to be it. I think we've covered all we need to cover. You'll have a homework assignment. Please get through the homework assignment, and then when I get back, we'll work on it together. Okay? So again, that is solutions to systems of linear inequalities. Peace out.